All right, there we go. Please give a warm ShmooCon welcome to Jacob, who will be presenting Putting on a Big Show, Defending by Attacking Attacker Incentives.
All right, thank you everyone for coming. I know this is the coveted me between you and your lunch slot, so I do appreciate everyone that is here. And yeah, so let's get started because we are running a couple minutes late. So real quick, I'm just going to talk about deception, both from what I've seen as an outsider and then as I've slowly started to learn about it, and how we see it at Thinks Canary. Then I'm going to hit my mental model for conspicuous deception, which is kind of what this whole talk is about, and then a couple implementations, one of which is kind of like ready and, you know, out there, and then the other one is more of like, you know, first steps. And then we'll wrap up and hopefully have some time for questions. So real quick, I've been kind of in different places across the cyber kind of field for the last 15 years or so. I ran some teams at AWS Security, kind of in the AppSec role. I was a DARPA program manager. I got to fly an F-16. Is this slides not? Oh, it only works there. Okay. Look over there, everyone. And then before that, I was doing hypervisor, OS kernel type research. So now I am at Thinks Canary, Thinks Labs. I'm new to the deception space. It's kind of a weird place for me to be. And so I'm still learning a little bit about it. And so this is kind of some of the things I've seen and you know, what I've picked up. So now I work at a deception vendor. We're not here to sell you anything. Everything that we're going to talk about is going to be open source or free and given away today. But I have been in the audience both as a PM, you know, you kind of always are getting pitched ideas, as well as, you know, just kind of going to RSA. I've seen the deception hype cycle. You know, I hear that it's the next big thing, and then I've seen it. Now we have no slides. Okay. It's deception, not like stealth. All right, well, you can imagine that there is a slide showing how excited people get about deception, and then when it doesn't work, people are a little more upset, and then maybe they start to actually get some real value out of it. There we go. We got 1 out of 2. Perfect. So kind of what you usually see, and I'm sure some of you have been to an RSA booth or a Black Hat booth or been pitched. You see something like this. You see a picture from one of the previous world wars where they have an inflatable tank, and then of course you have to quote, you know, the master Sun Tzu, and so they throw a slide, you know, a quote from him about why you have to have deception, and then it never really goes beyond that. Like, I've never seen it and hit that tipping point to something that really creates a lot of value. And so, you know, coming to Canary after it's been around for a number of years is very different, right? So, you know, in my mind, deception exploits the information asymmetry between a defender and an attacker. And so if you can deploy deception in seconds or minutes, then forget about it. You have no more cognitive load, but an attacker who's trying to understand and learn what's in your network, they have a lot more to sort through and try to get themselves you know, oriented. And as they're stumbling around, they're creating noise. They maybe are alerting you, or at least they're not being able to like maximize their attack because they're kind of confused about what's going on. And so real quick here on the left is what our hardware canary looks like. And then it looks like it's a Windows server, and it takes about 20 seconds or so to deploy on your network. And now you have a Windows server that if people start interacting with it, you know, you start getting alerts, and you can start kind of getting at least a little bit of a tripwire. On the right is the Canary tokens, which are kind of smaller subsystem level tripwires. And so in this case, one of our canonical examples is we will vend you AWS keys. You can get a unique set for every single laptop in your organization. You can put them anywhere. And if an attacker who gets on that computer sees, ooh, they have AWS credentials, what's behind that magic gateway? They then open it. They see, oh, well, actually, it's a canarytoken.com key. I've just gotten busted. And on the right, you'll see when I hit manage this token, it's kind of small, but you can actually see that we got an alert that someone is calling get caller identity from that. And so this is it's a free way. Like, you go to the canarytokens.org right now on your laptop. You don't have to sign up or anything. You just get this for free. And so this is kind of the idea behind Canary tokens, and this is kind of the thought process that I've been seeing in the deception space since I've come to Thinks. And our thinking seems to be working. we do have a lot of love, public and private. Just recently, someone used an AWS key in their Circle CI environment to detect unauthorized access, and then a few days later, Circle CI says, hey, we've been breached. And so that was a quick, easy way for someone to be able to get a level of trust in their vendors and be able to understand like how secure or insecure they are. And then we also get reports from red teamers who get caught by us, and it changes their behavior or at least pisses them off. And so it kind of works in this way. But something that I didn't expect, I started seeing as well. So privately, we get a lot of love as well, and you start to see this strange sentiment of, we don't want to tell anyone that we use you because then, the deception gig is up. And so we want to keep it very private, don't share our logo, don't talk about us as customers. And so they have this sentiment, which I always think was a little strange, because I've always seen the fact that there is something like that altering behavior. And so this led me to a very brief stint, jokingly, in BizDev, because think about to that token example. As soon as they get caller identity, they see they're using a canary token, and they're like, crap, I just got caught. So what are they going to do? Next time they come to AWS keys in some organization, unless they need to get through there, they may leave them alone if it's not part of their objective. And so we had a red team recently attacking us. So we gave them access on a laptop in our network, and we said, go ahead. And then we watched to see what they were doing. And obviously, we have a lot of canaries running in our environment. Every employee has some for their home as well. And they did nothing. They just sat on that laptop terrified to try to scan or go outside of there. And so it was a pretty, not great report for us. We didn't learn a lot about how we can improve because they didn't do anything other than say, well, this laptop that you gave us access to, we could access it. And so this is also, like, you can, on that one slide that works, you can see that now this is, a red teamer who now is altering their behavior, and they're changing how they work through your environment. So they're going to be slower. They're not going to be able to exploit your environment quite as deeply, and then there's going to be that kind of concern in the back of their head. And so my BizDev joke was that we should offer a Canary Basic program where you pay us $100, we send you some t-shirts, and we tweet, hey, thanks XYZ Corp, for buying 50 canaries. Love to see that they're all deployed. And then if an attacker is researching XYZ Corp, they see that tweet and they go, maybe I'll go elsewhere, maybe I have to be really slow, maybe I have to find some other things. And so, jokes aside, that's kind of where we're at. And so that's what we're calling conspicuous deception. So we're overtly signaling that we are lying to you about capabilities and maybe that they're deployed. And the maybe that they're deployed, thank you very much, is actually a pretty cool thing as well, because organizations that do nothing still get a little bit of benefit from that. So stepping back a little bit, what do attackers want? I mean, it feels great to pop a box and get root and domain admin on an engagement, but at the end of the day, that's really not what their goal is. They want something else from that. And different attackers want different things, right? So there is some reason that they're going after an organization. It could be fun, they want street cred, they don't like an organization politically, they want money, which is a big one, or, say we are in DC, they want intelligence or to steal some sensitive information. And so by understanding the incentives, we can figure out how to kind of counter those, right? So money, obviously driven by financial incentives, intelligence, you're trying to either steal information to understand what your adversary is, or farming access for later, if you're going to tie it with something else. Political is kind of one of the weird ones because most of the other actors are fairly rational, right? Like a ransomware crew doesn't go and spend $10 million buying a bespoke exploit chain and then asking for $2,000 ransom. Like they want a payoff at the end of the day. Someone who's politically motivated may just kind of waste so much time because they're driven for it. So that's one of the more difficult. They're not necessarily a fully rational actor. We also talk about attackers being on a spectrum of technical sophistication, so people who are like script kiddies or running low orbit ion cannon versus the APTs with their 0 days and their sophisticated stuff. I think there's also another spectrum of attacker sophistication, which is what I'm going to call translation, which is basically how easy it is for them to translate access into their goal. And so I'll talk through a couple of those, but I also want to call out that we're not the first people to think about attacking attacker incentives. So Dino Dizovi, he gave a great keynote at Black Hat Asia a few years ago, and he had this kind of fake quote of I rob banks because that's where the money is. And you think about it, very few people enjoy robbing banks. It's not a fun experience, but you get lots of money, and that's where the money is, and so that's why they do that. And so, now we're going to look at some of these different types of attacks and attackers and like their translation sophistication and how we might be able to go in and disrupt that. So ransomware is the easiest one. You take something they want and you say, give me money or else something bad will happen with it. Either I'll encrypt all your data and I will only give you the key if you give me money, or I'm going to reveal all your embarrassing, Outlook PSTs unless you give me money, and then I'll delete them probably. And so there are some ways that, right off the bat, like if you can back up and do recovery drills and advertise that you can get back in and operational very quickly, that is some preventative measure. And I think that's what's really cool about conspicuous deception, is that you can move from a reactive alerting capability and something that slows down attackers, something that may actually cause them to find another target. As if they think that you can recover your operations in a few hours, you're probably not going to pay a big ransom. And then another one is this idea of chaffing or chafing. So basically wheat and the chaff, separating those out. If you can intermix fake data with real data, the threat of revealing that is less compelling. And it provides a little bit of plausible deniability, a little bit of concern of maybe that data is not real, and so it kind of decreases the value when that is being made public. Moving to more, kind of traditional data theft. So this is a breach. You may not necessarily want to get caught. You don't contact them and try to get money out of that. And they'll have different kind of goals depending on what they're going after. So like I would say a very low sophisticated in terms of translation, they want to get monetary gain very easily. So maybe they steal a credit card or something like that, a PayPal account, and then they can pretty easily turn that into money. I talked to one organization. They were a high frequency trading firm, and they had lots of money moving back and forth very quickly from various positions, and they had, a huge amount of value in their positions research. And they were compromised by an attacker who just stole their FedEx account number and then left, because it was easier for them to monetize shipping stolen goods on eBay than it was to monetize this, incredible gold mine of financial information, because they were a low sophisticated in terms of translating from data into access, into value. Medium is kind of the middle ones where there's a little bit more effort. So like medical records, they're incredibly valuable, but you have to know how to tap into that value. And it's a little bit more complicated. You need to have a more formal structure of someone is stealing information and then someone is monetizing that. It might be a separate organization. And then last, kind of the high tier, this would be more like, the APT group, where if they're stealing the schematics for a fighter jet or a missile, someone has to be able to extract value from that, and they're probably not the same people. They have, essentially a very structured organization to exploit that information, and exploit being the intelligence gathering of making use of that information rather than exploiting getting onto a system. And so all of these pieces of data create value based on the assumption that the data stolen is correct, valid, and useful. And that's where we're getting into here. So we need to attack them by hitting those incentives, right? So they need to be able to use stolen data to create it into value, and so we want to be able to demonstrate the feasibility, at least, if not more than feasibility, of breaking that translation from data into value, publicly show it's possible, like go speak at a conference in DC in January called ShmooCon, and then that maybe now anyone could have deployed these publicly available defenses, and now there's something sitting in the back of every attacker. And so now we also want to help make potential attackers aware. So later there's going to be a call for everyone, if they like this talk, to share the ideas and everything like that so that people start worrying about it. And then you also get the reactive benefit, right? So when you do get an alert on your canary token, that still is valuable, even if it didn't necessarily prevent an attacker from going after you. And that's a lot easier because now they need to move in a different way that might not be their standard MO, because they're worried about, say, using AWS keys or something like that. So today in this talk we have two instantiations. The first one is a useful tool that we just released. You can start using it now. And then the second one is more of taking this even further. It's still very early, not production ready, but I hope it will spur some thinking and some discussion, and I'm happy to collaborate and share what I'm working on with anyone that's interested. So if you think back to a few slides ago, we drop that AWS token, we forget about it, and then you get an alert saying, hey, someone just accessed the AWS keys on your CTO's laptop. Now you know exactly what device they're in, you know which computer they're on because you have a unique set of, say, AWS keys for every laptop in your organization. And then either you can now quickly respond to that and maybe shut down that laptop, or attackers start getting wise to it and they're like, well, I'm just not going to go after AWS keys unless I really need to. And so we're doing the same thing with a new token type today, which is going to be a credit card token. So this is how we're going to try to attack credit card fraud. So if you go to canarytokens.org, which is our free Canary Tokens site, you can click Generate Credit Card. It will give you a real credit card. It's not just the Lund check. This is like a real, legit credit card that is active today. It will decline all transactions because I don't have the budget to pay for everyone that goes on there. And it will alert on attempted use. So either webhook, email, and then for our customers, we can feed it into Splunk or SIM or whatever you want right there. And then just deploy one everywhere you think it may get stumbled on, right? So if you do store payment information, right? If you are a first-party payment processor, put a couple there. If you have multiple branches of your location, put one everywhere so you can start understanding maybe if there's only a partial compromise. You know, a previous job, we'd have a Word document on a shared folder with everyone's corporate credit card number, and then the executive assistants and the travel team would use that to book travel for us. Stick a couple in there that they know not to use, and then if someone's like, you know, an insider or something like that, and they're ready to, you know, punch out, and they want to grab as much information, now you know that you have that to kind of clean up. Also email, like PSTs, that's a really easy one regardless of if you have Exchange or Gmail or whatever. There are a lot of companies that you send them an invoice and they say, please charge this credit card number, and they respond with the full credit card number in the email. So it's not that out of the norm to find credit cards in an Outlook Exchange. And there are actually tools that will grep basically through these things looking for the credit card number signature so that you can monetize that. So yeah, stick one there too. And so this was one that I generated a few days ago. You know, so Kyle Lowe is a fake name, obviously. My name is not Kyle Lowe. The number is valid and the CVC number is valid. There's no billing zip, you'll see, because it doesn't actually matter. So when you try to do a transaction, it's kind of like going and asking a big organization for approval. Everyone has to say yes, and anyone can essentially veto the transaction. And that's what happens. And so when you get the number, it's okay, the number is valid. Does the name match? No. Okay, that's like a hit against it, but sometimes you don't even have the name. So is the CVC valid? Yes. Oh, that's good, that's good. Does the zip match? No, no, okay, that's not great. And then you can even do things like, you know, Stripe has a system called Radar, which is kind of like AI fraud detection. So if they've seen someone swiping and getting declined multiple times from an organization or one store, they'll start flagging future transactions like, hey, until we know that there's not some guy with a stack of, you know, credit cards he made trying to test them all, let's just kind of block that one down. And so it could be the legitimate card gets declined. So there are a lot of things out there that basically can prevent a transaction. The good news is we don't actually want you guys to spend all of our money. We want just to know that the transaction attempt occurred. And so then the cool thing with these is that you can ignore that. If it makes more sense to put it in under your name, that's fine. If you want to put your own billing zip, that's also fine. So you can essentially use all of that however you want. If you want to stick it somewhere programmatically, we allow you to download it as a CSV that does have, you know, like all the fields that would make sense, and then you can just stick that in, you know, a database or somewhere as well. So that's really straightforward right there. And as I mentioned, I'm going to hit on this again. The transaction attempt will be declined. We are not giving you free money. But the person who created it will get an alert. And so this is an example from my inbox. Basically, it will give you the merchant name. It will give you the last four of the credit card just so you can remind yourself which one it is. The token reminder, so, you know, put something useful in that memo. And then the transaction amount, it will try to grab basically how much you're trying to authorize it for. So on a computer that is not my own, I will try to do a demo. You can't see that screen, can you? Okay. I'm just going to type something in here, canarytokens.org. You guys can follow along if you'd like. Yeah, I'm going to, yeah, 1 second. I can't type very well looking that way. And someone has very nicely volunteered to let me do this semi-fraudulent transaction against their web store. So thank you. All right, so I will try to do this blind. Okay. So I have a tokens.org, canarytokens.org. Is that the credit card one? Someone who can see it? Yes. Okay. All right. And then is it selected the field? If I put, okay, did I type jacob@things.com? Cool. All right. And then we'll put this in, you know, our Outlook PST file. And then I will, it does take a couple seconds. Did I click on it? Yep. Okay. It does take a couple seconds because we're actually generating a real credit card and issuing it and all that work. And there you go. So now we have a real credit card number. This is going to be really challenging for me to copy and paste all of this without being able to see the screen. Was that? Okay. I may only be lying to you. This is a talk after deception, but I will be honest. I'm going to go to Binary Ninja. I understand that I'm purchasing a non-commercial license because I am an attacker, and every attacker needs a good disassembler. All right, put in my email address, attacker@attacker.com. All right, and I'm just going to nicely copy the information. There's a little UI field that helps with that, which is pretty slick. All right. Copy the card number. Expires 01/25. And the CVC. All right, what's a good zip code for here? Like 22203 sounds reasonable. All right, so now I will click. Hopefully it says declined. Okay. Jordan, did you make money yet? Okay.
He paid for that.
So it does take a couple minutes for it to flow to the transaction, like the Amex people, and then down. So if anyone has a question right now, it takes like 2 minutes. Go ahead.
You only offer American Express credit cards, or do you get other things?
So right now we are, oh, I need to go fast?
Repeat the question.
Oh, sorry. The question is do we only issue Amexes? I will talk about that more. Right now, yes. We are trying to add that, and that's actually part of the selling point of this is the more bank identification numbers we can issue and the more card types, the harder it is for an attacker to throw them away. Right now, maybe attackers just say, Amex, not going to worry about it. Yes?
Question is mostly, what type of credit cards do you use? Visa, Chase, what type of banks? Credit cards?
So we're open to work with anyone. Amex is their own, oh, sorry. The question is which banks are we open to working with?
Yes.
And anyone who wants to work with us, we think this is a cool idea. We think this will, nip at credit card fraud, which is $40 billion a year. So if anyone works for a bank or an issuing platform and would like to talk to us, please do. All right.
Is there a way to get a physical card?
Not unless you pay us money.
Repeat the question.
Oh, can you get an a physical card? So most of the times our issuing platform will pay, charge us money. We were actually talking about doing this as business cards, so our own business card, like what would you keep a business card in your pocket for from a random person? So we would actually make it so that there'd be a QR code on the back. It would be a real credit card with one of these tokens. You scan the QR code the first time, you put in your email address, and then any subsequent time, if it's swiped, you get an email, or if someone scans the QR code, you get an email as well. So that we're thinking that would be kind of a cool business card, make it look like a corporate card or something like that. You'd keep that in your wallet as a physical token. But right now, we haven't got there yet.
Question.
Yes.
So these are persistent in that you can continue to leave this thing up there for different attackers. It's not a one and done.
Yes. They will continue to be, sorry.
I thought I was loud enough.
The question is after this is triggered, do you need to go and regenerate and reinsert? And the answer is no. These will last until they expire, which is about 2 years. All right, now try. Did it say it's
Because the audience is playing along with you.
cool? So it's been triggered. So sometimes it triggers multiple times if the error code comes back as like temporary issue. So for example, I've noticed that Stripe will actually try it twice in quick succession. You should only get one email as long as they happen in a certain amount of time. This also could have been some joker who is also going in and trying to do it. So if you like click on that, you should actually see, I don't know if that actually says like $300 something from, okay, so there you go, it worked, perfect. Sorry that the demo was kind of clunky. All right. Okay. Cool. Glad that worked. All right, this is a video, if it didn't work, showing you the same thing. We don't need to watch it because we already saw it. So, some caveats about this, right? So this is now available. It does have beta in parentheses. It does obviously rely on more third parties. We are not yet a core issuer. And so we're trying to work on more card types and more bins. So please do keep it track. And then as we add those, they'll just start getting mixed in randomly. So that way you'll just kind of get a MasterCard one day and a Visa the next day, hopefully. We have run into one payment processor that if you've paid extra with them, they can do some form of validation before they issue a transaction. And so they can check if the zip code is correct before they actually say, I'm going to spend some money on this. And so they won't alert because they'll say invalid zip or incorrect information, check again. All the big ones seem to work just great, but that may be something that you may run into, so it's not 100%. And then also, kind of going back to your question, unlike our other token types, you do need to think that these will expire after a couple years, just like credit cards expire. And so, you know, if you have this stuffed in a payment database, you do need to set a reminder, hey, in 2 years I need to go back and add a new one in there. But that 2 years is pretty good. So it does require a bit more upkeep than, say, the AWS tokens, where you can just literally forget that you even put them out there and then you get an alert. Just like certificates, yes. So now what? This is a public tool anyone can use. Anyone that has a laptop can go and do this. And now attackers have to be cautious about monetizing stolen card information. I'm sorry, attackers, if you're watching this. And the cool thing is even if a target organization doesn't employ these, if they store an Amex, it could be one of these. And so, you know, now everyone gets a little bit of preventative benefit just from the fact that this exists. And so again, share this with your community, tell people about it, put some on your organization's network, and you're helping kind of add to that shadow of doubt. Now obviously unsophisticated attackers that don't go to ShmooCon or watch our live stream, they're probably going to just continue to do the test thing and they're going to get caught sooner, which is great, because currently what happens is someone recognizes a fraudulent charge on their card, they report it to their bank, and then the bank has to go and see, okay, where else have people been shopping that have also reported fraudulent transactions? And that can take a while depending on people's spending patterns. Now the moment someone tests this card to see if it's active, they know, hey, everything in this database is compromised, let's go lock it down. Sophisticated attackers, as I mentioned, will probably generate a lot of these tokens and capture the bins. So the first number is like, is this an Amex or a Visa? Then the next few numbers is basically what bank was this issued by? And then the last number is like the account number, and that's the unique to this card. And so they'll probably generate a bunch, and they'll start seeing which of the bins we're issuing from, and then probably discarding that, which is actually a great sales pitch to onboard a bank to this platform. Say, hey, banks, would you like it if sophisticated attackers threw away your customers' cards when they breach an organization? And then hopefully they'll say yes. And then they'll onboard it, and then we'll give more bins, which will make it harder for an attacker to be able to figure out which ones are legit and which ones are tokens. And then also it means that, you know, those legitimate customers are now protected from fraud because they're not going to be, you know, used by a sophisticated attacker because they're worried about that. And so hopefully that's like a good thing for everyone. So that was the first instantiation of conspicuous deception. So now we're going to go again. I want to highlight this one is like cute, super early. I think there's something there, but it's not quite cracked yet. So at its core, as I mentioned before, deception is this information asymmetry between defenders and attackers. I talked a little bit earlier about like chaffing. It's not a new concept. I think there's a Rivis paper from 1998 that talks about how to get data confidentiality without encryption by adding bogus data around it. And so it's hard to deploy though, and it generates, kind of, it's outside of our traditional use case of encrypt the data and protect it. And so this new concept, Deception DB, is a very much proof of concept trying to make this deployment easier. And so all you have to do when you wanted to protect an application is use my replacement PyMySQL driver, and then you need to provide the semantics of the table schemas you want to protect. So you may have a column named password, and the semantics of that is it's a SHA-256 hash of a string. And so you have to be able to tell that's what it should be generating to make it look like that. We have a lot of baked in, like, social security number, phone number, names, all that kind of stuff, but also like you can generate, give it a custom function of what I want to generate. And then basically it just generates silently fake rows, and I'll talk a bit about how that actually works in a little bit, and then it filters them out when the application is using them. But if you get root on the database and you say select everything, you're going to get all the data, which can be programmatically up to like 90% bogus. The example I want to talk about is medical records. So medical records are very expensive on the dark market, black market. They are between $200 to $1,000 each. Credit cards, for reference, are like 15 to 25 cents. They're used for, medical records are used for nefarious purposes, and also they're much more long-lasting. You can't go call your hospital and say, I'd like to delete my entire medical history and regenerate one. I think a lot of people would mulligan on their health care if they could do that. And so, some of the big ones, insurance fraud, right? So if you get a medical record of someone that has kidney problems and is on dialysis, you have their insurance number, you have their social security number, you can bill their insurance company and say, hey, I provided, Joe Bob dialysis, please send me $1,000. And that's a pretty common problem with the insurance industry. And so that's one of them. Obviously, identity theft is, very concerning for people who are impacted by that. And again, it's not something that you can go easily and regenerate and cancel your social security number and your entire banking history. But we also note that the data itself is, again, an enabler that has to be translated into value. Right? If you're doing insurance fraud, you want money. If you're doing identity theft, you generally want money. So if we can impede that translation by ruining that data, we can then devalue it and hopefully, disincentivize the attacker. And what's interesting about medical records is that they are technical, but in a different domain expert. I'm actually a volunteer EMT, and so I do have a little bit of medical knowledge, but I would say most attackers probably can't look at an x-ray and understand if that person is dead or whatever, if it matches. And also the last thing is that generative AI models are all the rage. And so while people have been making cat pictures, I've been making x-rays, CT scans, and MRIs. So I say, Dolly, make me a CT scan, and I don't know if someone's dead. I don't actually know what part of the body that is, but it looks real to me. And so this MySQL driver, it uses GPT and Dolly to basically generate patient narratives and medical images. And then we're able to then stuff those in. So MySQL and some of the other databases have what's invisible columns. So unless you know the name of the column, you can't query against it. So if you run select star on a table with an invisible column, that column's data will not come back. You have to say select star, comma, long column name to get that information. So unless you know the name of the column, you're not going to get any of the data. And so essentially what I can do is I can have an extra column there that stores state about whether or not this was generated or not. And so again, that's the really rough edge. It's not perfect.
The question is mostly when you look on the scans and you figure out, like, from that point, even though the skeleton, can you filter that into the column? The question is, if you know the science or the medical reason, can you put that in the filter in the column?
I think the question is can I filter off of the medical records being real or not?
Yeah, so when you do the filtering in the column,
Yes.
can you, like, if you know a little bit of medicine?
So no, the medical stuff is too difficult to be able to filter out automatically. Now, obviously, if someone steals this and they hire an army of doctors or nurses to go through and say, hey, their chief complaint was a broken thumb and I see a chest x-ray, like this one we can throw away. but that's going to cost a lot of money and probably not provide the value they want. This one I can't demo because it was running there, so conveniently I planned ahead, and so we will just quickly walk through this. Essentially, I built the most ugly patient medical system, an e-health record system on the left. Is it playing? No, it's not.
Still better than the federal one.
You haven't seen the real ones.
I haven't seen what?
You haven't seen the real ones.
I guess I have not, yes. So it basically lets you add users, so that would be doctors, and then patient records. And on the right, you're seeing me, I'm logged in as root, so this should be see everything right here. So you see I've just done nothing, there's nothing in the database, there's one admin user that comes pre-configured. I create myself as a doctor, I give it a password, and then you'll see on the right, I'm gonna rerun that command, and you should see not one new user, but 2 new users. And so, like, that's really nice, because if you spend time cracking that hash for David15, the web app is going to filter that out anyways because it can't see that that exists. So you're now wasting your time. And I turned this down to only generate 1 fake record per insert. You can do this 100 times or whatever, so you could really bloat yourself up. So now I'm going to create a fake patient record for John Doe. I added another user. You can see now that there's 5 users there, of which a couple of them are not real. So this person has a fracture to the left wrist, and this is just some kind of, trying to make something sound medical. Patient arrived with a chief complaint of something out of 10 pain in the left wrist after, fall to that area. They were x-rayed and, sent on for, home or whatever. So hairline fracture, and then here's a fake image of a wrist x-ray, save the record, and now you can see this is what the x-ray looks like. That looks pretty good. Like again, like I'm not a doctor, not a radiologist, but Dolly said that's an x-ray and it looks pretty good. And you select now you're looking at this, so now you see there's 2 records here. So Victor Adams is a 55-year-old male, booked an appointment. He has some chest pains, and he was worried it was serious, so he came in. And then this is the Dolly photo that it generated to accompany that. So now you're going to see basically the medical image that they have generated for this poor patient. And actually, we got really lucky. It randomly picks a body part to x-ray. So we got very lucky that the narrative said chest, and we got a chest x-ray. So good for you, random chance. So this was kind of the demo of that. And so this is something that you can very quickly add into any existing web application or other types of thing that uses database. But there are definitely some issues with that, right? So there's a lot of rough edges, not including my web design skills. And then obviously, if you can get SQL injection before the driver, depending on how you do it, you may be able to get real results through the web application. So it may actually filter out the fake rows. So there's still a little bit of work to be done with that. And then obviously it adds a lot of pain to a database admin who's trying to go in and make legitimate changes. So I think there's something worthwhile here. I think there's something valuable here. You just got to figure out exactly how to make it really seamless. And so it's just kind of a cute idea, but it's not there yet. So in conclusion, right, we're making this credit card token public and freely available. Like everyone asked when I told them, why aren't you charging for it? Because if we charge for it, then people, the attackers will think, oh, it only really thinks customers would have this. And so by the fact that anyone could have one of these, now they need to worry that everyone might have one of these. And they always need to worry about this poison pill that in a dump that will ruin them all. And it's a preventative measure against fraud. And hopefully by mixing bins into our system, attackers will have to discard stolen data or risk alerting on it. And I think that this idea of conspicuous deception can go beyond just credit cards. I showed you a demo to that extent. Obviously, we still have more work. But the cool thing is that the costs are really only storage and a little bit of compute time. It doesn't really cost that much to store, a couple extra pictures. You can make them small and then a couple extra rows in a database. And you can get a really interesting, preventative measure from that. I've also heard this called security through obesity. Where you just fluff everything out there, and now it's really difficult to know what's real. So obviously, if you're a bank or a financial institution, please reach out. There's my email. And then otherwise, I do have one last thing that was kind of cool. So some of the folks here who are more government If you're in the defense industrial base, Dolly can also generate semi-realistic looking schematics for fighter jets. And so if you're worried about someone going in and grabbing those, maybe go and spend a few minutes on Dolly and download some pictures and stuff them in there. So with that, thank you very, very much, and I'm happy to take questions. The question is how do database administrators validate which is real and which is not? So in the current prototype that I have, there is an invisible column that's called checksum, and if it's a random number, and if that random number is even, it's fake, or if it's real and it's not. So that's what I'm doing. I'm basically, every query that goes to database, I'm also adding a where this hidden column is odd or even. So if you select all, it's not going to show the invisible columns. They don't show up. If you do a describe table or you look at it on disk, it will show up. So then you would know. Yep. Yep. The question is there an upper limit on the number of canary tokens that we can create, like an issue to you? Yeah. So the answer to that is, for the credit card token, we're not sure. It shouldn't be an upper limit. We'd like for people that this will benefit to actually use and to kind of densely deploy, but we don't know. And for AWS tokens, there's no limit. We have organizations that have tens of thousands, hundreds of thousands of them throughout their organization. For this, we'll find out what happens. The question is, do we have a revenue stream for these canary tokens? No, it's good publicity. So hopefully, people who like our products that we give away for free. One of the cool things, if you're a paying customer, you get a private canary tokens instance that doesn't have the canary tokens URL and domain in it. And so then also you can tie alerts for your canary tokens directly into your SIM or however it can generate a Slack alert. So there are some benefits, but realistically, $40 billion of credit card fraud is going to bad things, and if we can make a tiny dent in that, I'll sleep better at night. So that's the real thing. Okay. Okay. Perfect. Yeah.
Finally, good use case for NFT.
Yes. We get a lot of Twitter spam. So the question, I guess, was a comment, good use for NFTs. Because we do have the tokens domain, you would not be it's shocking how many people mention us when they're releasing a new NFT type because they think we're in the token space. And so our Slack channel that gets all of our mentions on Twitter is just constantly flooded with people doing an ICO or a token release. So, yeah. Yep.
Your alerts, is it only email, or you do other things like integrate with a SIM or anything of that sort?
So the question is the alerts only email? Email, webhook, and if you're a paying customer, they'll feed through into a SIM or however you have it set up. Okay, and I'm done. Thank you.